All right, everyone, it's 2:10, so we're gonna go ahead and get started. So the weeks on these slides are like a little bit off, but welcome to like week 9 or 10. We're making a slight bit of a shift from the rest of the semester's content so far. We're gonna move into plotting using Jupyter Notebooks today, which is why we kind of started switching you guys on Tuesday. It should be like a little more of a chill lecture, so if you guys have felt kind of overwhelmed by all of like the NumPy stuff that we've been doing, this should be like a little bit slower. So thanks for showing up in the middle of midterm season, and we're gonna get started. Okay, so Python can do a lot of super cool stuff with plots. Here's a few examples. I don't know what the top two are, but that bottom one is actually plotted using Python libraries that we're going to teach you guys today. So that's pretty sick. Um, we're also going to look at one other way of launching your Jupyter notebooks other than what we went over on Tuesday. So if you have Windows, go ahead and open up your Anaconda prompt app. And if you have Mac, go open up your terminal and then we'll give this a shot. I'll give you guys like 20 seconds to get that ready. Okay, I'm assuming you guys have your either Anaconda prompt or terminal open. So a little shortcut that we can use to opening Jupyter instead of clicking the Anaconda app and then waiting for that to open and then launching Jupyter from there is you can use your terminal window or your Anaconda prompt and just type straight in here. So the command that we're going to use, and this might not work for you and that's okay, but it should work for most of you, is, that's still kind of small. Okay, it's going to look like this. Jupyter Notebook. And then it should open up all this crap again. Um, and then it'll open up your notebook. So I'll go back and show the command again. It's this one. So just type that like exactly as is into your terminal or Anaconda prompt, and then it should work. Okay, can you go ahead and raise your hand if you have a notebook open? Okay, great. Is anyone having problems with this? Like it's just not working. It doesn't usually work for me, so. Okay, great. So let's move on then. I'm just assuming that it worked. While you have your Jupyter notebook open, try not to like close your terminal window if you have Mac because it'll shut down your notebook. So just leave this open. Okay, so from here, just do what we did on Tuesday. So head back to where you keep all of your code files for this class. And then we're going to go back to slides, but we'll come back to this in like a little bit. And then you can make like a make a new notebook while we're at it. Okay, so while you guys do that, I'm gonna go back to the slides and then I'm gonna keep talking and then we'll come back here in like 5 minutes. Need to find the slides. Where'd they go? Okay, so that was fun, but let's actually talk about plotting now. So to actually use any of the plotting stuff in Python, it doesn't come, I guess, natively. It's built in through a separate package like NumPy. You have to import it in order to use any of the functions that are involved. So for Jupyter, don't pip install anything. Just leave it, ignore that for now. If you wanted to use it in VS Code, you'd have to do the pip3 install nightmare that we did on Thursday. But we're not going to do that right now because it comes with Anaconda and with Jupyter Notebooks. So don't pip install anything right now. To use it, all we have to do is import it, import matplotlib.pyplot as PLT, and we're going to get to that in a second, but that's how we use it. The reason it's called matplotlib is because this is like a Python version of the MATLAB plotting library. So that's why it has that name. Okay, I recommend you guys just like take a picture of this really quick because it's a lot of syntax. And once I move off the slide, you're not going to have it anymore. But this is the basic good practice structure for making a plot using matplotlib.pyplot. So just to walk through this really quick, we can ignore this for now. This is the default inline. If you wanted to show up in a different window outside of your notebook, you would change that to something else, but we're not going to do that right now. You import the library, as we saw just a slide before, and then this plt.figure basically gives your notebook like an empty space to work with. So this is like the object in your notebook that will hold the plot. So you should always try and include this line. The next line is plt.plot, and this is the line that actually does the graphing. So you give it X data and you give it Y data, and then this will make your 2D plot on the figure that we just made. Make sure the plot shows up. It will show up without plt.show, but you should include this once you're done with plotting, because when you get to plotting multiple lines on one figure, you're going to want to make sure that you have something separating each of your graphs. Otherwise, everything will show up on one plot and it'll look really bad. So this is like the figure sandwich that we try to teach you guys. You have figure at the top, you do the actual plotting, and then you display it. So this is like a good way to structure your graphs. Yeah. Yeah, so they can be arrays, they can be NumPy arrays, they can be lists, they can be scalars, but usually you're going to give it like a list or an array. And they're both. I recommend you guys take a picture of this one too, just because this has all the syntax for labeling that you're going to need to use like over and over and over. But if we look at this, we can see we start with the basic figure again. We do the actual plotting. And then if you want to give it a title, you have to start all these with PLT. Give it your title, X label, Y label. The legend is not so relevant in this example, but you would use this if you have like multiple different lines on one graph. And then you show it. I think, Richard?
Okay, so now let's do a like demo for using the basic syntax of plotting. So first we need to import NumPy as we commonly use as NP, and then import matplot dot py dot s plot. Sorry, I don't really remember, but let's see if that works. Okay, that works. And then we'll define the X and Y values. So let's see, we want X equals to NP namespace from 0 to 2 pi. And then we want 100 like numbers in this array. So we can also print X to C. And then we can also define Y as, let's see, we want a sine function. So it's gonna be like this. and we can run to see what is x. So yeah, we're basically having some x values from 0 to 2 pi. Yeah. And then we're going to create the plots. First, we're using the what Pranati just talked about, and then yeah. And then just in between the two lines, we're putting something like first plot x and y. And basically from here we can already see something. And then we can add the title to the plot. Let's see example. And we can also add the X and Y labels here. See how okay, so here we have a like basic figure of the sine function. And if we want to compare the anyone has questions on this part? Okay. Yeah.
What's the last number in like that lit space function?
Here, the 100? Oh, it's just like 100 numbers for X. Yeah.
Like it, how much?
The length, yeah. Nice. Any other questions? Okay, I'll just go ahead. If we want to like also compare the cosine function with the sine function, we can define another function and we're like going to plot it on the same figure. So from here we can define y2 equals to np dot cosine x. And we have another like array of x2. And then we want to plot it on the same figure, so we just put it here. After the first like function we have plotted, and we put x and y2. And yeah, basically now just to like distinguish between the two, we may want to use the legend. You can put anywhere like you want, but I'll just put it here. Legend. And here we have like two functions together, and to distinguish between them, we're giving them like two names. The first would be sine, and the second would be cosine. And we also want to like, yeah, let's do this first. So round the like second box here to give the x2 and then this one. So we have two functions here. And here we found that it's yeah at the like lower left of the figure. But if we want to change the location, we can also like put another parameter in the like legend here inside the legend here. Like we can just simply try it. So location, and then we can change it to upper right or whatever. Oops. Oh, yeah, comma here. Yeah, and then you can change the location of the legend. But yeah, basically that's plotting like with this. Yeah. Any questions so far? Oh, sorry. Let me know if you have any questions or you like I can like wait for a second. Yeah. The legend. I would say like if you like you can see that you're defining some parameters here. Like the first are the legend's name, and then you also define the location of it. So if you like remove this brackets, it will be something that are not maybe accepted by this kind of like function. Yeah. So yeah, inside of a bracket, you're just putting the name of the two or whatever numbers you need. Oh, sorry. Oh, yeah.
So PSA, because everyone's having really similar problems. So when we put in the import statements at the top of the notebook, we put them in a different cell just by convention. Most people do it like that. You have to run this cell before you run the rest of the cells. So you're getting errors that say like MP is not defined or PLT is not defined. Just try running this again. You may not have run it the first time, and that should fix it. And if that still doesn't fix it, then like raise your hand and take a look.
Yep.
Is there a way to run all of them at once?
Maybe we'll run
Yeah,
it.
yeah, you can.
The run button runs all of them, but the shift just only runs the cell.
I'm not pretty sure about the shift, but you can just press the round button here. Yeah.
Is there a way, like, is there a setting that I can turn on, like, on, I don't know about everybody else, but on here, I don't have any labels on the line numbers.
The line numbers, what do you mean by, that line numbers?
Yeah.
So you can go to view and then it shows like show line numbers. You can-
Or I think Shift plus L should work, but
I think
not
that's
sure,
like the
yeah.
programming shortcut. Or you can just go to view. Any other problems for before we move on?
Yep. Any other question? Yeah.
You have to like specify a specific order of labeling these things.
Uh,
Like, you label for.
label for, so sorry, uh, you mean like for the order of these two functions or? Oh, I believe you don't need to like do like that, but I would say like do plot first where you don't have the functions on the figure. Yeah. Any other questions or I'll just move on? Okay. Sorry. And I just, okay. Ooh, sorry. Oh,
All right.
the, oh, I made the slides?
Yeah.
Oh.
Oh, this also just disconnected. Okay. They're like up here, the
Oh,
hidden by the Zoom window.
sorry about that.
Okay, yeah.
Yeah, and I will, like, as we just talked about, the examples could be like very not that good looking or so you may want to, oh yeah, this one first. So yeah, there are also other types of plots. You can also use scatter to do some like scattered points on the figure, and also you can do the bar plot, which is like this histogram here. Yeah, and yeah, we can also customize the plots to add some colors and change the like kind of like formats or how it looks by these following like syntax. So first we can change the color of the plots we just made. You can try this on your own Jupyter notebook or VS Code. So like you can just add the color equals to red or like R after the X and Y, and then you run the codes again and you get the functions like you get the lines in the red color. And you can also change the size of the line by using the line width. You can make it equals to whatever like numbers you can like, I guess just some random numbers you can put in to see like how that works. And basically the larger the numbers are, the like wider the lines will be, like thicker. The lines will be, yeah. And you can also use the like marker parameter to define like the shape of the markers, like the points you're drawing. So if you use the like the star sign here, you will just make it star shaped. And there are a lot of different things you can put in here, and you can just search it online. Like you can also use I believe like O or whatever other things to change the shape of the marker. Yeah, and you can also put the color and the marker shape together by using the like R star here, as you can see. Yeah. And then you can also change the opacity of the figure by using alpha parameter. So you can put 0.5 or other numbers to change like how transparent you want it to be. Any questions on this? Yeah.
If you just like changing the color, change the color of like both of the lens if you're using the color.
I would say let's go back to the example. Yeah, so yeah, you'll just change the color like inside of each, and you'll change the corresponding one. Yeah. Oh gosh. Yeah, and you can also change the size of the plots just by like when you create the canvas for the plotting, you just put the fig size equals to parentheses, and inside parentheses you put 12 8 or 7 5 just to define the ratio of the width and the length of the figure. And you can also add arrow bars to your plot by using the plot plt dot arrow bar, and then you put first you put the xy, and then you have to put like the y arrow, like ERR parenthesis parameter equals to y arrow, which you have to like define this earlier before you draw your figure. And yeah, and you're gonna use the FMT equals to some shapes. You can also find this online to like define the formats, like how you want the point to look like. Yeah. Any questions so far? Oh, yeah.
All right, so let's do it then. Bro, okay. So let's see. So we're gonna go back to the plot we just made, and we're gonna go try to apply as many of these as we can. The goal is not to make a readable, understandable plot. We're just gonna try and jam as many of these as possible into one graph. So either like take a picture of all these different changes or just try to remember them in your brain, because we're gonna go and like stick them in. Okay, I also took a picture of it because I forgot. So let's go look at the matplotlib.plot documentation for this. So you can see I've been using a lot of Googling for matplotlib recently. Okay. So this is like a really, really short definition. It just says dot plot and then args, which is super cool and awesome. And we know that that's not exactly what we're doing because we gave it x and y, and we gave it x and y too. So there's something else that's going on in here that it's not showing us. But if we scroll down and we just keep going, and then we keep going more, we can see the actual parameters means these are the actual arguments that we can pass in. So instead of giving it args, this is what we can actually give it. So here we have x and y, which we saw we gave it arrays. We can also give it single numbers and it'll plot one single point. And then we have all this other stuff that we can give it. And then we have like these keyword args, which are special things, which is actually everything that we just talked about. So if you see this thing that says like kwargs, that's short for keyword args, and they're just like special arguments that you can kind of throw on the end that are optional. So this is all the fancy stuff we were just talking about. So here's the alpha, the color, you can use dashes, the fill style, this is like kind of extra, the label, line style, line width, marker, and then all of this other stuff. There's just a lot in here. So if you want to ever change how your plot looks, go to the docs and just scroll down until you see all this list of interesting keywords. But if we go back to our demo, we can start trying to apply some of these. So did anyone who took a picture of the previous, actually, let me just go back to it. Okay. So we have 4 things we can change. And I want you guys, every single person who's paying attention, to hold up 1, 2, 3, or 4 fingers, and then whichever one has the most, we'll start with that one. So number 1 is color, number 4 is opacity. So pick one and then raise your hand. Okay, we're getting a lot of 3s, which is interesting, and a lot of 1s. So let's start with 1 and then we'll do 3. Okay, let's change the color. Changing the color, I think, or picking the color, I think is the most important part of making a graph. So how do we do that? We can put it directly into this. Can you guys in the back see this? Is this still too small? Okay, it's good. So this is where you add it. So we have our plt.plotline here. And then we saw that it's a kwarg, it's a keyword arg, so you stick it on at the end. And we're gonna call it, I think it's literally just called color. So what color do we put in here? Like, can we just give it like red, blue, whatever? The answer is yes. So let's just try red. And there we go, now our line is red. And someone asked about this earlier, but because we fork it into the plot line directly, it only changes that line. So one of them is still blue. This is like the default color. But yeah, just throw that in at the end. Now for what colors you can do, we're gonna go back to the docs to figure that out. You can see I've been here before too. But Matplotlib has a lot of really fun colors that we can use. And again, this is the most important part, so we should spend lots of time trying to figure it out. So there's a lot of colors here that we can pick from. So if you guys remembered how I got here, just Google Matplotlib colors. And I'm gonna give you guys 2 minutes to go do that and then pick your favorite color, and then we're gonna go change it. So go here, and then out of this entire list, you could pick like a blanched almond if you want. Just like pick your favorite one, and then we'll do it. Okay, it hasn't been 2 minutes, but we need to move on. So did anyone find a color that they like really spoke to them? Yeah. Medium spring green. Is there like a non-medium spring green? There is not. Did anyone find another color that wasn't medium spring green? Yeah. Okay, Rebecca purple. Is anyone's name Rebecca? Okay, that works out really well for us then. So any other ones, or we're just gonna use those two? Light pink. A lot of nice pinks. Okay, great. So let's see, yeah. Where?
You can set the color, you can, numpy or, not Kotlin, like you use like hex.
Yeah, I was like, are you giving me the hex code right now?
Yeah.
Okay, yeah, so if this isn't enough colors for you, you can in fact specify the RGB value in numbers if you want, or you can give it the hex code, that's also valid. So yeah, 56A, totally an option. But I think we're gonna use medium spring green, Rebecca purple, and light pink. I'll just add another line. Okay, I'm just gonna add another line so that I can give it a third color, because I think that's worth it. So let's set our colors. All right, that looks nice. I'm surprised. That actually looks really good. But those are the colors that we chose. Again, you can use whatever colors you want, but these ones actually came out looking really nice. If we understand how to do that, I'm gonna show you guys another way of specifying labels. So for this one, we gave them as a list and then said where to put it. There's another way to do that, so we can take this out and just give it the location, and in each of these lines, we can give them a label. Was this sign? Yeah. And then that also totally works. This is one that I usually use because for me, it's a little bit more intuitive, but adding it as a list is also totally valid. Okay, so now that we did, I just got a UC Berkeley warn me, don't go to Berkeley Way West in Shattuck, I guess. Yeah, so good thing we're in class learning about how to make plots, and we're not over there. But if we've got this, we can move on to some other stuff. So I think the next most popular one was marker type. So let's move on to that one. Similar to the colors, it never ends with markers. So let's go look those up. As you can see, I've also been here before. And we can see just from those pictures that it's going to get crazy in like 2 seconds. But here they are. If you guys you guys should go here too. So Google Matplotlib markers. Put that into Google, make it bigger. And then click on the first one, the official docs. And then you're also going to go find your favorite marker. And then we're going to put them in. So over here, the marker is the actual text we're going to put in. And then the symbol is what it's going to look like. So there's a lot of these. You can give it a pentagon. You can give it a hexagon if 5 sides was just not enough for you. You can give it a thin diamond. There's a lot. There's a lot. You can give it, oh yeah, you can give it F strings too, but we're gonna look at these for now. And I think you can also give it like custom shapes, but we're not gonna do that. There's 2 types of hexagons, which I think is pretty fun. One of them is rotated slightly. So that's pretty exciting. If you want to get crazy, you can use hexagon 2 instead of hexagon 1. Anyways, I'll give you guys like 20 seconds to find your favorite shape, and then we'll put them in. All right, what shapes did we find? It's been like 20 seconds. Give me a cool shape. Like cooler than hexagon 2. Yeah.
Center net base.
Okay, that was kind of long. Carrot down center net base. Okay. You had one too?
The marker is really nice, it's like
Yes, this thing. Look at that. I don't know what that is. It's a try left. That's what it is. Okay, so we got two.
Num size 1/8. That one, the star-like symbol with num size which is.
Okay, I'm gonna find it. My page is like so zoomed in, I can't see my search bar. Okay. Oh, one of these. Ooh, okay, so I think this is like a custom polygon. Like we give it a number of sides, and then we give it an angle to rotate it. So this is if like hexagon 1 wasn't good enough, hexagon 2 wasn't good enough. We need a hexagon 3. We need like an octagon 4. That's what you would do with this one. So we can try this one out. Let me go remember the other one. So we had 8. We'll call it caret left base. Oops. Mark it equals caret left base. And then the other one, it was 3. It was this weird thing, just number 3. I've never used custom polygon before. So we're gonna see if that works. If it doesn't, I might make it hexagon 2, just so we can move on. Oh, it didn't work. Okay, let's see what I did wrong. Yeah, I think we should use the official symbol, which is lame. Okay, so we have to call it 8. Yo, I put in my crazy stars. I put in my 8 190. That's pretty exciting. You can see them here. Look at those. They're like little spiky balls. Pretty awesome. I don't know when I'm ever gonna use that, but it looks sick as hell. Okay, so if we scroll down, we can like take a look at what the hell this ended up looking like. So we have, so what did we do? We made the inchworm, the green one, with, what marker was this? 8? Oh, that was the triangle centered at base. I guess there's so many triangles we can't really see them. And then we have the spine. That's pretty cool. And then we have these like snowflake thingies. So I think if you turn this graph into like anyone who wants to take you seriously, they would laugh really hard. But I think it's awesome. So let's change one more thing. Does anyone have any questions before we move on? Yeah. What do you mean?
Like, the first time we ran it with the first marker having like the words,
Yeah.
it didn't want to go through, but then when I changed it to a number, it still didn't want to go.
Oh, when you change it to 8, it still didn't work?
Yeah.
Is it 8 like as a string?
Yeah. It's just like.
Mhm.
Oh,
yeah, that has to be, so the marker, the like special polygon, you have to put it in parentheses, not quotations. So if that's tripping you up, that's the reason. Yeah.
Just.
Okay. Anything else? Problems? Yeah.
This is just a question.
Yeah.
And would it be mad if you said like alpha is over one? Would it bold it? I just want to be there.
Sorry, yeah, I can't do that. If you want to make your line really chunky though, we are gonna do this anyways, but I'm just gonna do it right now. Change the line width. Someone give me a number. Unbounded. 0 to something. Anything is up for grabs. Just raise your hand and tell me a number. 13. Look at that thick ass line. Nice. You can't even see the markers anymore. That's how big it is.
Is there a limit?
Sort of. It was like a heuristic limit, but I'm pretty sure you can give it whatever you want.
That's sick. That's awesome.
You can also give it decimals. In this case, it's getting swamped by the markers. Oh my god, what width was that? Yeah, look at that. Thick line. And put it back to like 10. So another thing we can do is we cover different types of plotting methods. So we can go ahead and change these, just change these to like scatter. And it looks, okay, that doesn't look the same because it's super fat. And put that back. Let's change the spine. Think, is this one? Yeah, this one's the spine. Okay, so it's kind of hard to tell, but when I changed it to a scatter, it took out the connecting line. So now it's just the markers. Okay, this makes it like a little bit more clear. But yeah, so if you change the plot keyword, okay, you cannot see that at all. If you change the plot to scatter, it'll remove the connecting line. So that's why the spine one, the purple ones, doesn't have a line between them anymore. Okay. You can change the alpha too, which is like the transparency. So now it's like super pale. Okay, it looks the same on here, so make it more pale. 0.1. Okay, yeah, so now it's like really, like she's low on iron, like she's pale. That's what alpha does, it's like transparency. So this is helpful if you have like a lot of stacked lines, which we do.
Did you make it something markers or
Oh, I actually went and I changed this. I changed the lint space to only have 50 slots. Just to space everything apart. Okay, I'm gonna show you guys one more thing and then we're gonna move on to actual content. Because that's enough having fun. Let's see, which one do I want to do? I'm gonna put the alpha back to 1, and then this is one more argument that we can do. It's called line style. And this, you can use the line style argument to give yourself like dashed lines or dotted lines or anything like that. So I change that to like dash dot or something. Then this will give me, okay, I'm gonna get rid of the markers. Okay, so now it's a dash and dotted line. The green one. And to show you guys the thing again, it's this one. Line style plus dash dot. So that's like everything you should need to know for customizing plots. Color, the most important thing, and then marker, opacity, line style, line width. Any questions? Okay. Let's go back to content. Let me find the slides. Okay, time to cover my least favorite thing in plots, which are subplots. Oh my god. So you do subplots if you want to do a big figure with more than one plot in it. So this is like one big figure and then it has 4 separate graphs on it. So like what we did before, we stacked lines onto the same set of axes. Not for this, baby, they're all different, they're all separate. They all have their own. Well, these have the same x-axis, but they don't have to have the same x-axis. They can have different y-axes, different lines, they can all be different. So this is helpful if you want to compare plots next to each other. This is what I just said. Okay, how do you do it? So the unfortunate thing about subplots is there's like 6 different ways to make them syntax wise. This is one of them. I think this is one of the easier ones to do, so I think we're just gonna stick with this. But yeah, let's just do it in demo because this is kind of hard to like look at and imagine. Yeah. Subplot time. All right, again, I hate subplots so much. I despise them with every fiber of my being. So let's do it. Okay. So to make subplots, the syntax is slightly different because of course it is. But so remember for the figure sandwich, we do plt.figure. Not for this, baby, it's different. We're gonna do fig and then AXS. AXS is short for axes. But those are like the little mini plots inside of the big plot. So the previous one had 4 mini plots, so it had 4 axis objects. And then make it a little bigger. plt.subplots. This is how we make a subplots like figure. And then what we're gonna give it next is what we want our grid of plots to look like. So if we want to make a 2 by 2, we would give it 2, 2 for rows columns. And we can give it 3, 3, and that'll make us a 3 by 3 grid. I don't think this has to be, I think you can give it like 2, 1, and it'll give you 2 and then like 1 on the bottom. So if we want to actually put stuff in here, how do we do it? And the way that this works is this little axis thing that we just put in is going to be like a bunch of different axis objects smashed into one variable. So we call each grid object by going AXS, and then we want to know which one of those grid plots to access. Like we had the 2 by 2, like which one am I going to plot in? So we're going to tell the program that in this line. So we say like 0, 0. And from NumPy, you guys are like a little bit familiar with 2-dimensional indexing. So I'm going to give it the row, which is the first 0, and the column, which is the second 0. So this is going to be top left one. We're going to find out. But it should be the top left one, the very first one. And then we're going to plot in here. So instead of doing plt.plot, we're going to give it this access object and then plot on that. And if we run that, we can see that it gave us the 2 by 2 and then plotted as right, it was the top left corner. And if we don't give it anything for the other graphs, they're just going to be blank. So now we have 2 different graphs on 2 of the different plots. I'm not going to fill in all of them because like you can see how it works. But if I wanted, okay, exercise time. I'm going to put a plot in this one. What would I put inside of these braces? Instead of 0, 1, I want to plot in here. What would like the first number be? 1. What would be the second number? Perfect. Oh my God, you guys are so smart. That's how you would do that. And we can do all of the same stuff that we did in the previous plot with like changing line color, et cetera, in here the same way. I forgot my plt.show, don't tell anyone. So we can change the color. I just remember that one for no reason. And then we can change like the line width and everything. Yeah, there we go. So that's how you do subplots. And I think we're like basically out of time, so I'm just gonna stop here. And feel free to ask any questions or just like head out. Thanks for coming. Yeah. Okay. Any other questions? All right, perfect. Have a great rest of your week. And remember the homework deadlines are coming up, so keep working on those.